All right, here comes problem 65, page 267. It is the second and last of the two problems that I'm going to do for you. For your homework 18, you have assigned problems 63 and 69. And this problem says find the inverse of f and then find the domains and ranges of everybody, both f and f to the minus 1 of x. So let's go ahead and find the inverse. The manner in which you do that is basically compose f with its inverse. Let's go look at f of f to the minus 1 of x. It's equal to, every place you see an x, you put in f to the minus 1. I see an x down here, I'm putting it in, there's a 2. So here's 3x, 3f to the minus 1. Here's x, f to the minus 1, plus 2, there's the plus 2. And if indeed f to the minus 1 is the inverse of f, then f of f to the minus 1, since those two functions effectively undo one another, if they are to be inverses, then f of f to the minus 1 is x. And all we're left to do now is solve this equation for f to the minus 1. 3f to the minus 1 is equal to, if I multiply both sides by this quantity down here, here's the x. Here is the f to the minus 1 plus 2. That's equal to x times f to the minus 1 plus 2x when I distribute this x across this sum. If I bring this back over to the left-hand side, I get 3f to the minus 1 minus x f to the minus 1 is equal to what's left, 2x. And I get f to the minus 1, 3 minus x is equal to 2x, and therefore f to the minus 1 of x is equal to 2x all over 3 minus x. So if I would, there's the inverse of this function. If I would like to check that, and gosh knows I want to check it, all I have to do, let's do this. Let's go set up f to the minus 1 of f of x. Let me compose now. Up here we composed f with f to the minus 1 of x. We said it was x. Let's compose f to the minus 1 with f of x. So I'm taking f to the minus 1. Every place I see an x, I'm going to put in an f. So here's the 2. Here's an x that I'm replacing with 3x over x plus 2. Here is 3 minus x, but I'm going to replace that x with 3x over x plus 2. I'm going to multiply the top and bottom, all terms, by x plus 2. I'm going to get, the x plus 2 is going to go away. It's going to leave me with 6x. Down on the bottom, I'm going to get 3x plus 2 minus 3x. And so let's look at this. I've got a 3 times x minus a 3 times x. Those terms are going to cancel. I've got a 3 times a 2, which is a 6, and that will cancel this 6, leaving me with x. Hallelujah. Yay. I can't spell yay. Yay. Okay, let's kind of quickly knock off the rest of this problem. If this is f of x, the domain of f of x is clearly all reals except x equals minus 2, right? And if we were to plot this function, good Lord, what we're going to find is this function has a vertical asymptote here at x equals minus 2. It's got a 0 right here at 0. And it's got a horizontal asymptote of 3. All right? So let me plot 1 point for us. If I put in 1, I get out 3 divided by 3. I get out 1. So 1, 1 is the point. So it looks to me like this function is doing something like this. And therefore, when we look at the range, the range is all reals except this one right here, which is, what do we say, which is y is equal to 3. And so we can make use of that to kind of quickly write down the domain of the inverse of f and the range of the inverse of f, because they are related to the domain and range of f. In particular, the domain of f to the minus 1 is equivalent to the range of f. So this is all reals except y equals 3, and the range of f to the minus 1 is essentially the domain of f. So this is all real except y equals minus 2. And on we go to problem to homework 19.